Hello guys and welcome back. So let's continue and take a look at this. I have the front and back wall, and I have the brick main geometry, the bricks geometry. So I'm not interested in the bricks at the moment. I just need this guy. So let's disconnect this and let's create let's copy all of this. Okay. So with this geometry, it's it's different or trickier to get the edges that we need to preserve. So what I'm going to do is I'm going to use the include by edges feature, and I'm going to use the min edge angle in this case, and right away you can see that based on this topology it's working. It's giving us this information, which is what we need pretty much. And I have two groups here. I have one called wall front and wall back, and these two pieces are basically the front and back. I'm gonna keep them here just to show you guys how I'm gonna deal with the geometry at the same time, all the geometry at the same time. And what I'm going to do is I'm gonna say for this guy I want to operate on the wall front and just use the edges. Okay, and obviously I'm not going to use the same value here, so let's try 0.1. Let's try 0.2. That's too much. Let's try 0.5. That's still too much. Let's try 5. I just need more resolution in there, that's all. Enough to get some edge details in there. Okay, let's stick to this. I want to keep the geometry high res so that you guys can see this working. Okay, so the next thing is the noise and then the fracturing, and boom, it's working. So let's take a look at this, and I'm gonna call this main, even though it doesn't matter. And we're getting some cool fracturing now. Now I'm gonna do the same thing for the back wall. The back wall is actually quite messed up, so before we do any of this I want to fix that. And as you can see, it's an n-gon. It's a face with more than 5 points, so it's not gonna work, and there is no way it's going to work. Now after we did the rematch, this group information is not valid anymore, so we have to regenerate that again. And I'm gonna copy it, just it's the same value, same curvature. I'm gonna use this remesh node, and the reason I did this is I don't want the same resolution on the front and back. And let's see, I think the reason for this could be the it could be the fact that the group changed, so I should have cleared that up. But I'm gonna copy the file quickly, and I'm gonna open it again. So here we're going to work on, okay, so let's see, I'm gonna work on the wall back, and I don't need that much resolution, so just 0.2, maybe 0.1, because this back here is not going to be very visible. Okay, so that we have that, we can do our fracture, and we can restore the geometry. Let's take a look, flat shaded, and there we go. We have our edges, and everything is working as expected. Now the next part I want to do is I want to loop over each one of these guys, and as I did before, I want to fracture it in a different way. So I'm gonna use this guy, and let's make sure that we have a name attribute. So we have a name attribute, and that's what we're going to use to loop over all of this. So I'm gonna convert this into a volume. That you can see the volume there. I'm going to use a volume wrangle node to increase the density so that I can easily see it. So f at density, I'm going to multiply this by 100. Okay, so that's working, and let's increase the resolution a bit, and we can scatter some points. Now I want to add some noise to this volume. I want to break both the shape, the way this looks, and the density. So let's create a volume VOP, and let's dive inside. And I'm going to use a volume sample node to read in the density data. So first input, and the primitive name is density, and let's make sure it's density here. Yep. And I'm going to create a noise pattern, and let's add that noise, and let's make sure it's a 3D noise, and this is going to allow us to distort the volume. Right now it's very high, and as you can see now we're getting different results. Actually, I'm not going to use the density variation because I think this already is enough to get breakups in the volume, and this is going to affect the scatter, obviously. Let's delete this. I want to keep this constant, just the seed. I want to make sure that that changes. And here we have the same noise. That's fine, let's keep that, and let's restore that. And as you can see now, it's looping over the pieces, and it's really fast. So I'm pretty happy with the speed of this, and I can easily iterate over each one of these guys, control the way the noise looks. I think here it's probably too high, so I can easily change that. So 0.06. Okay, and I can change it on the piece level as well. So if I don't like this, I can simply come in here, increase the resolution or the amplitude, and let's lower this to 5, 5, 5, 12, 12, 12, something like this. And now we have very interesting pattern that we can use. And you can see here, this crack, for example, has a different look compared to these guys. And that's very, very important when it comes to creating a realistic look, because these T or conjunctions that you get, they don't have the same pattern. They don't have the same noise on them. Okay, so what I want to do next is we can keep on doing this. We can just copy this guy, paste it, and we have to make sure that the name attribute is up to date, so we have individual attributes for these pieces so we can loop over them. And in this case, the name attribute is not correct. Okay, so we have to fix that. I'm going to use a new node, and just refresh or fix the name attribute, and it's going to figure out everything. And look here, even with this geometry, we're still processing this really, really fast, and so that's great. And it's going through this guy, so I'm going to lower this to 4. And it's going. And there we go. We have very high res destruction already, but for this layer we're not planning to go very high res because we want to have enough details to create the destruction, and then we're going to create the up res later on. So one way two things that we need. We need a way to identify the groups of clusters of fracturing, so I can say, okay, these guys were fractured together, this is the root piece for them, so we can get a group for all these guys, and then I can get a group where it only contains the secondary fracture, and then another one, and so on and so forth. And what I want to do, what I want to be able to do, why is this not the case? I'm just checking the colors here. I guess I have to go back and yeah, preview this, for example. So one thing that I like to be able to do is to have these levels as components, so as separate nodes. So I just add a node, and then here I can set the specific settings for that node, and I can for example, choose the ratio so it doesn't affect everything, and I can copy them with other nodes. So if I like a pattern, if I like specific thing, it will just be a matter of copying that node and sharing it. And here you can see the original blocks there, and then the secondary fracture, and we've got rid of pretty much all the issues that the noise has. We have edge displacement, and we have geometry that we can easily use for destruction. Now with destruction, it's actually, we don't have to have this much details or even this this geometry itself. We can do, let me cache something quickly. So I'm gonna cache this here. So with destruction, we don't have to have this exact geometry used in destruction. So what I can do is I can use a poly reduce node and loop over this and say I want to keep 10% of this. Maybe that's too much. 20%. Okay, and you can see it gave me a really nice representation of the geometry, so we don't have to worry too much about even pushing the edge details and having the high res here. And if we loop over this, we have a very low res representation. Now with the poly reduce, we're only using 20%, and actually the less points we have, the less points we pass to bullets, the happier it's going to be. And all these edges and stuff is not going to be contributing to the resolution, to the quality of the sim, but it can affect the speed quite a bit. So that's pretty much it. We can use this and then deform or render this original geometry we have here. Now in the next video we're going to improve this. So what we need to do now is we need to package this into an OTL or an HDA where we have and expose the exact settings that we need. Okay, so it would be primarily the noise. I want to keep it really simple. It will be the noise, and it will be the number of pieces, the scatter. And then we're going to have a restriction. If we're doing this fracture for the first time, the node is going to work just fine. But if we're adding secondary or third level, we have to provide an information for it or an attribute that it can use to do the looping over it. Use that attribute to know which pieces to fracture together. So that's something we have to design into the OTL, and then we'll expose the control for the volume fracturing here, and we can expose, maybe add a ratio so that not all the pieces get fractured the same way, using some if statement and a switch system. So we're going to start implementing that in the next video. Thank you guys for watching, and see you in a bit.